Producing multi-language technical content creates a severe operational bottleneck. The sheer friction of researching, drafting, and translating complex engineering concepts across different languages requires massive manual labor, eventually stalling even highly capable teams. To publish a single article, a team has to run a sequential gauntlet of manual tasks. They must research credible sources, write a comprehensive primary draft, translate it twice, preserving technical terminology, optimize the SEO tags, design consistent UI components, and finally execute a quality review. That baseline manual workflow demands over 6 hours of continuous human effort. When calculated at standard rates, a single article costs approximately $312 in pure labor. This chart compares that standard manual timeline against the output of TekiNGame's multi-agent automation. The towering 6-hour execution block on the left collapses down to exactly 15 minutes on the right. As the time requirement vanishes, the financial burden plummets. The cost per article drops from $312 to exactly zero. They did not achieve this compression by purchasing a monolithic, expensive enterprise SaaS solution. Instead, the engineering team built a custom matrix. They deployed 239 highly specialized AI agents, chaining them together to execute these tasks sequentially. Achieving enterprise-scale automation requires abandoning the concept of large language models as passive chatbots. The leverage is found by re-architecting them into dynamic, tool-using microservices. Standard large language models hit a hard barrier when answering technical questions. Without access to live external data, their reasoning scatters, forcing them to rely on outdated memory and resulting in hallucinations. TekiNGame's solved this at the foundational level by using the React agent as their base operational unit. React stands for Reasoning plus Acting. A React agent does not simply generate an immediate text response. It runs a continuous dynamic loop, querying external tools and gathering missing facts before it ever formulates a final answer. This flowchart tracks the React loop for Ethereum. The reasoning node states, "I need the current price." The action node triggers a web search. The observation node ingests the price. Being recursive, it immediately chains a calculation tool to run the final math. This entirely autonomous execution runs on basic Python, the free tier of the Google Gemini API, and simple web scraping libraries. Embedding the React framework forces the AI to verify its own logic against reality. That loop transforms a static text generator into an autonomous software execution engine. Deploying one Python React agent is simple. But scaling up to 239 distinct agents triggers severe configuration management problems. Prompts overlap, instructions conflict, and the system descends into chaos. TekiNGame imposed order on this system by creating a structural taxonomy called the guild system, a concept drawn from role-playing games. They compartmentalize the 239 agents into 17 distinct clusters. This allows each group to act as an isolated microservice. You can see the labor division: 18 agents in engineering, 21 in content, and 15 handling design. This creates an incredibly efficient routing system. If a developer needs query optimization, they don't have to sort through a global repository. They pull the exact agent they need directly from the data guild. The guild system proves that structural hierarchy is the only way to scale complex AI workflows. Without strict organization, the architecture collapses under its own prompt management debt. There is a common assumption in software development that AI automation requires massive, do-everything monolithic prompts. In practice, high-yield output requires hyper-specialized constraint parameters. Looking at the SEO strategist system prompt, you can see it does not ask for general optimization. It enforces strict mathematical limits, like a 60-character maximum for titles and specific schema markup. The multilingual translator agent uses similar boundaries. To prevent terminology drift, the agent is forced to cross-reference an internal engineering glossary, maintaining strict technical uniformity. Over in the Design Guild, the team applies these precise constraints to visual outputs, utilizing a design system generator built for automatic UI and UX configuration. UI design often suffers from human inconsistency, like one developer using 16 pixels of padding while another uses 20. The agent prevents this entirely by enforcing mathematical spacing scales that lock design choices to a rigid system. This code snippet shows how the agent automates color generation. Rather than manually picking hex codes, it calculates accessible palettes using precise hue, saturation, and lightness math. These programmatic outputs are guaranteed to be WCAG compliant and are instantly exportable into modern front-end frameworks. General-purpose AI often produces average results, but highly bounded, mathematically constrained agents drastically outperform them because their operational scope is so strictly defined. Combined, the React engine and Guild taxonomy operate like a high-speed asynchronous relay race, all set in motion by a single user request. This horizontal schematic tracks the exact sequence of the handoff. The research agent pulls data from the web. The writer drafts the content. The translator duplicates it using the engineering glossary, and the SEO agent injects the final tags. However, there is a vital operational constraint governing this pipeline. The agents handle 95% of the execution, but the system relies on a mandatory human in the loop. QA agents are excellent at catching logical flaws and broken code, but human operators must execute the final 5%. They review the output to ensure brand voice, cultural nuance, and ethical standards are perfectly aligned. Over 6 months, this 239-agent architecture generated concrete performance metrics. Publication volume increased by 300%, the human error rate fell to 0.5%, and the system eliminated $180,000 in annual production costs. Beyond direct financial metrics, this architecture freed the engineering and content teams from repetitive operational drudgery, letting them focus on high-level creative strategy and research. Achieving asymmetric leverage in modern production relies entirely on replacing manual execution grinds with rigorous, distributed AI architecture.